Hi Victorians, we're going to go through this planning exercise on solution. In particular, this planning exercise makes use of your knowledge of solubility of salts, KSP, qualitative analysis of cations, anions, to enable you to distinguish a set of solutions and positively identify the individual solutions that make up the set. So if you can, since this is going to be a test of your knowledge of solubility of salts, I want you to just go and take out your notes on solubility of salts, and this piece of notes can be found in the introduction to qualitative analysis, which I've given to you during our first laboratory session. And if you can just turn to page 3, you should be able to find this solubility table here. This solubility table is very important, so I really urge you to go and memorize it for your theory paper, because in the theory paper, in the A-level exam, we won't give you this table, so it's good to commit this table to your memory. And then let's just take a look at how this table allows us to predict the solubility of salts. Okay, since let us look at the first solutions over here, or let us look at all the solutions over here first, right? Okay, we have lead nitrate, sodium sulfate, iron 3 chloride, sodium nitrate, and sodium hydroxide. So all these, the first 4 are soluble salts, and the last one is a soluble hydroxide. So let's say you're in an exam and you are not sure whether sodium sulfate is soluble, so you should really just quickly run through your mind, and if you remember the table, we go to the sulfate part over here, SO4 2 minus. It says there all sulfates are soluble except for calcium 2 plus, Ba2 plus, and Pb2 plus. Okay, so you know that the sodium sulfate is soluble, and if it's soluble, of course it will form a solution. And let me just also go to the very basics of writing the solubility equation for a salt. Let us just take the sodium sulfate as an example too. We have sodium sulfate, Na2SO4 solid. Because this is a soluble salt, so it's going to dissociate completely to give 2Na plus AQ plus SO4 2 minus AQ. Okay, simple equations, but it will come in real useful later on in our next part of the explanation. Okay, so if you look at this table, okay, I'll fill in the blanks for you. This table is you're supposed to fill in the expected observations when pairs of solutions are mixed. So what this allows us to do is that when you have a particular solution, when it is mixed with other solutions, it gives either a PPT or no PPT, and by looking at the solubility in excess and also by looking at the color of the PPT, this table really provides you with a very rich information for how a solution will behave when it is mixed. And when you have such a wealth of information, it allows you to distinguish a solution from the other solution based on its behavior. You can see that this table is divided into half, and this half of the table is really redundant because since we are doing mixing, by the time you follow this order and you come to the last few solutions, you have done mixing of this solution in the previous part. So for this kind of table, we will just fill half of it. Okay, let us see how we can fill in one particular blank space of the table, and you can do the rest after watching this video, or if you have done it, well done, you can just go ahead and mark it. But for now, we are just going to go through the fundamentals of how we fill in a particular blank. Let us look at the first blank over here. Okay, how do I know that when I mix Na2SO4 and PbNO32, I get a white PBT? Now this should be going on your mind. Okay, let me just pop up the board. Okay, remember I wrote this equation just now. Okay, I'm going to write a similar equation for the lead nitrate, lead 2 nitrate. Okay, so I have PbNO32 solid going to become Pb2 plus AQ plus 2NO3 minus AQ. Okay, so we are not going to be too concerned about the stoichiometry of the ions, since this is a qualitative analysis. Now, because these two solutions, these two salts exist as a solution form, okay, so you know that we will have ions present in a solution. Now, when you do mixing, the mixing allows these ions to mix, these 4 ions to mix. Okay, now we are going to pair up the ions, positive with positive and negative with negative. Positive with negative, to see how whether they can form a precipitate or not. So in this case, I'm just going to mix it up like this. Okay, I have Na here. So once it's mixed, it can meet the NO3 minus from the PbNO32, and if I mix a solution, the Pb2 plus will also get to meet SO4 2 minus, right? So in the end, you got to ask yourself this: is NaNO3 and also PbSO4, are they going to be soluble? If you look at the table, looking at NO32, so all nitrates are water soluble. So in this case, over here, I don't see any PBT. And for PbSO4, okay, all sulfates are soluble except for calcium, Ba2 plus and Pb2 plus. Okay, so over here I get a white PBT. I get a white PBT. Okay, and because I have the formation of lead sulfate, I get a white PBT. So I will write down white PBT over here in this box. Okay, let us go through one more. Okay, in this case, I will go through, how about this one? Okay, the mixing of FeCl3 with Na2SO4. Okay, FeCl3 with Na2SO4. Okay, just I have FeCl3 solid dissolving to give Fe3 plus AQ plus 3Cl minus AQ. So what I'm going to get is this. I have the Na plus here meeting the Cl minus. So I will form NaCl. I have the Fe3 plus meeting the SO4 2 minus in the solution. Fe2SO4 3. Okay, and then I will check for their solubility. Okay, over here. Okay, so it says there all chlorides are soluble except for Ag plus and Pb2 plus. So over here I will have no PBT. And for sulfates, all sulfates are soluble except for, okay, so I get no PBT either. Okay, so no PBT. Okay, so for both salts, I don't get a PBT. So in this case, I would write no PBT here in this box. So if you go through the exercise for the rest of the boxes, you will find that you will be able to come up with all the observations here in the boxes. Okay. And for each correct column, you'll get 1 mark. Okay, so let us go to the questions. Okay, so the question here is one of the solutions can be identified just by observation. You are supposed to identify the solution and explain how this is possible. The answer is iron trichloride, because iron trichloride is a pale yellow solution, while the rest are colorless. And let's just take a look at this over here. Okay, you have lead nitrate, which is a colorless solution. Sodium sulfate, again, is colorless. Iron trichloride, colored. Sodium nitrate, colorless. Sodium hydroxide, colorless. Okay, so by just looking at the solution, you can positively identify iron trichloride. So it's good to go and memorize all the color ions if you haven't, and the color ions to remember for our context of assessment would be these four ions actually. Okay, over here, also in your notes. Okay, so you have the chromium here, the chromium 3+, which is green. Okay, and you have the copper 2+, which is blue. You have the iron 2, which is pale green, and the iron 3, which is yellow. Okay, so now in this case, since FeCl3 is going to be a solution of low concentration, it's going to be a pale yellow solution. Okay, so by color, we can identify FeCl3. Okay, now since we have identified color already, I'm going to tell you how we can use this fact to therefore identify all the unknowns in our set of solution. Okay, so this is what is happening now. I have 5 solutions that is unlabeled. Okay, let me just have 5 solutions over here, and this is positively identified as FeCl3 AQ because of the color. So these solutions here still remain as unknown. Okay, and you know that they all appear to be the same colorless unknowns. Okay, now remember what I say about because the addition gives us a wealth of information. So this is what we're going to do. We are going to add this solution, FeCl3, which we already identified by its color, into this solution. I'm going to add it into this solution. I'm going to add it into this solution, and I'm going to add it into this solution. Okay, and this will give us another 4 observations. And we see what we can do from here. Now, follow me closely. Let's say if I have this solution, this first one, as NaNO3, and I have this solution as PbNO3 2, and I have this solution as what are the others? NaSO4 and NaOH. Okay, I have Na2SO4, and this one is NaOH. Okay, now if you add this to this, and this to this, and this to this, and this to this, can you see that we get different observations? Now, famous precipitate reaction. If you have iron 3 with sodium hydroxide, you get a brown PPT, right? Okay, so this should be new to you. For this one, you get a brown PPT, and this brown PPT is insoluble in excess reagent. Okay, if you add FeCl3 to Na2SO4, you get iron sulfate, sodium chloride. Nope, you get no PPT. How about for this? You get PbCl2 and FeNO3 Okay, so this one you get a precipitate because lead chloride is insoluble. Can you remember? I'll just show you the graph here. Let's see the table here. Let's see chlorides. All chlorides are insoluble except for Pb2 plus. So PbCl2 is slightly soluble in cold water. Okay, so I will get a white PPT here for PbCl2. Okay, so over here I get a white PPT. For NaNO3, I will get sodium chloride and I will get iron nitrate. Nope, I get no PPT again. Okay, so for this one, they are all the unknowns. But using these observations, I can positively identify at least 2 solutions. Do you know what they are? Okay, now the first thing is we can identify if I add FeCl3 to a solution and if I get a brown PPT, that solution that is unknown will be NaOH because it gives a unique observation of brown PPT which doesn't appear for the other solution. I can also positively identify PbNO3 as one of the unknowns because if I add FeCl3 to an unknown and if it gives a white PPT, this white PPT is a unique reaction, right? Okay, so we have positively identified NaOH and also PbNO3 already. Now that leaves us with 2 solutions which are a bit trickier to handle. Okay, which is this thing, the NaNO3 over here and Na2SO4. Because these 2 solutions, after mixing with FeCl3, they both give us the same observation. So now we got to make use of the other solutions that we have positively identified to identify the sodium nitrate and also identify the sodium sulfate. Now let us go back to the table then. Since now we are looking at this section over here, the NaNO3, okay, this part, and also now NaNO3, it doesn't give a PPT with anything. Can you see that? Can you see that? See NaNO3. There's no white PPT form with PbNO3. There's no white PPT form with Na2SO4. There's no white PPT form with FeCl3. There's no PPT form with sodium hydroxide. Let us look at the sodium sulfate. Okay, sodium sulfate gives a white PPT with lead nitrate. No PPT with sodium sulfate. No PPT with FeCl3. No PPT with NaNO3, no PPT with NaOH. Okay, so I think we have a solution over here. We are going to make use of PbNO3 which we have positively identified to distinguish Na2SO4 and NaNO3. Okay, so if you are still unsure, this is what is going on so far. We have positively identified 3 things. Okay, we have positively identified the FeCl3 by color. Oh, I'm sorry. Okay, we have positively identified the FeCl3 by color. We have also positively identified PbNO3 2 because of the reaction with FeCl3. We have also positively identified NaOH because of its reaction with FeCl3. Okay, so we know this, right? We know this already. We know this solution after we pour it out, after it reacts with FeCl3. So using this solution over here, okay, I'm going to pour it into here, and I'm going to pour it into here. Okay, I'm going to pour it into here, and I'm also going to pour it into here. And when that happens, if I mix PbNO3 with Na2SO4, I get a white PBT. And if I mix PbNO3 with NaNO3, I have no PBT. Right? So in that way, I would have distinguished everything. This is what the last part is about. Okay, I'm going to go through very quickly with you. Now, using these solutions alone, plan the steps which will enable you to identify these compounds, record the expected observation and deductions. So the first step is to identify any colored solution. If you observe one pale yellow solution, that would be the FeCl3. The rest are colorless, so you cannot do any deduction. Then after that, you will add samples of the other 4 solutions to separate test tubes containing FeCl3. So these would be the steps over here. Can you see the arrows here? The arrows here? Okay. So if one tube gives a white PBT, it will be PbNO3 2. Okay, I just okay, if one tube gives a brown PBT, it will be NaOH over here. Okay, if for the 2 tubes that gives no PBT, it would either be NaNO3 or Na2SO4, which is this one and this one. Then after that, since we have positively identified lead nitrate, we are going to add the lead nitrate to the 2 unknowns. The solution that gives no PBT would be NaNO3, and the one that gives a white PBT would be Na2SO4. So in that way, you will have positively identified every single compound's solution in the whole question. So that's it for this question.